Okay, hello everyone. We're going to look at another example of a Turing machine here. And yeah, this one you can see is a lot different than the last one that we had. First of all, it doesn't have any yes or no states. Instead, it has this new state that says H. Okay, and this stands for halt. In other words, at some point, the Turing machine is going to come to an end, and it's going to stop going along the memory. And instead of returning true or false, it's just going to return whatever it happens to have written on the memory tape below. So let's look at the memory tape and see what it's set up for. So it looks like we have some kind of a binary addition problem here. This Turing machine has been designed in such a way that it can add together any two binary numbers. Okay, so let's watch it do that. It's going to add 1010 plus 1111, and it's going to leave its answer right along here as it goes. Okay, so it has scrolled all the way to the end, and now it's kind of looping back and forth, going to the left and to the right, and altering actually the problem itself. And if you look at this carefully, you can see how it's actually accomplishing this task. What it's doing is it is continually subtracting 1 from this number on the right. Okay, you can see it's taking away 1 each time it loops. And also it's adding 1 to this number on the left. So by the time this number on the right is kind of whittled down to 0, we'll have our answer here on the left. So there are two parts to this. You can see that there has to be some part of it that is continually subtracting 1, and another part that's continually counting up by 1. Okay, and it has finished. You can see that it's arrived at the halt state. This means that it's ready to reveal its answer to the world. And yes, the answer is here. It's 11001. Okay, that was the solution to the addition problem. Okay, so let's back up and kind of see how this is working. Okay, so I've restarted the Turing machine, and we're not going to walk through the entire thing because that would take ages. Instead, we're just going to kind of follow it for long enough until we kind of get the idea of how it works. So here's the initial state. It says to go right, and so that will happen initially. It'll go to here. And if you look at the arrows leading from this, it really only has one. The only state transition available to it is replace pound with pound, or replace blank with blank. Okay, so it doesn't have a state transition for if it sees a 1, or if it sees a 0, or if it sees a plus sign. So what does it do? It has to keep going to the right continually until this state transition is available to it. Okay, so let's just watch that happen. It has to go to the right and continue going to the right because it doesn't have a state transition for 1s or 0s or pluses. And now it's here. Okay, it does have a state transition for what happens if it reads a pound sign. If so, then it can replace it with another pound sign. Okay, and then it has landed on this state, which made it immediately go to the left. So what was this first part doing? It was just scanning all the way to the rightmost part of the addition problem. Okay, and like you saw from before, its strategy is to continually subtract 1 from this number while also adding 1 onto this number. And this plus sign is kind of just used as a way for it to keep track of which number is which. Okay, so what is it going to do here? It sees a 1, so it has to follow along this path. It's going to replace it with a 0, thereby subtracting 1 from the number. And it's going to land at this state, which will make it go left again. Okay, and what should it do here? It doesn't have any state transition for if it sees a 1 or a 0, so instead it's just going to keep going left until it sees this plus sign. So let's watch it do that. Left, and left again, and left again. Okay, and now we can follow this arrow. If we see a plus, replace it with a plus, basically ignore it, do nothing, just go left. But we've arrived at a different state. Okay, so now here is where we're going to want to add 1 onto this number. And if you think back to the first video, this little segment of it here should look familiar to you. This is just the binary counter that we saw from before, included as a little subsection here. So it's just going to follow that exact same logic. It's going to replace 0 with 1, and then go to the right. And then we're kind of back where we started before, so it's going to loop through and do that again and again and again. And the more interesting part is, what happens after it has, gone all the way to the end. It's going to follow this little inner part here where it continually goes to the right, replacing everything with a pound sign, essentially until it just leaves the answer on the board. Okay, so let me cut really quick and get it to that point so we can see what happens at the very end. Okay, so I have advanced this Turing machine a little bit, and you can see I've taken it all the way to the point when it's going to kind of add the last 1 onto this number. And then we're going to watch it as it goes backwards and clears out the rest of this so that it just leaves the answer on the board. So let's watch it do that. Right now it's in the left state, so it's going to keep going to the left until it sees the plus sign. Okay, so there it goes, and now it sees a plus sign. It's going to advance to this state, and it's going to follow this state transition where it sees a 0 and replaces it with a 1. Okay, and this was the very last add that it had to do. Now it's going to continually go to the right. Okay, and it hit the end of the number over there. And now it has the ability to replace everything with 1s here. Okay, this is the first time that it hasn't subtracted something. It's trying to subtract. It thinks it can subtract, kind of, but before it can, print a new 1 here, it's going to hit this plus sign. Basically, it sees that it's reached the end of the number that's on the right. Okay, so it has to follow this. And it basically now sees that it has hit the end of its operation. It's going to replace the plus with the pound sign. And it's going to continually overwrite all of these 1s with the pound sign as well. Okay, and there it's going to just finish blinking out the memory, getting rid of all the scratch work, and then it's going to halt and tell us that the computation is done. Okay, so I think that should do it for this example as well. I hope you found that interesting. Of course, with these very small Turing machines, they can be combined together to form much larger and more complex ones, much like this little binary counter was a component in this binary adder. You could implement multiplication, you could implement all sorts of other operations theoretically with Turing machines. So we're going to see in the future video or in a future lesson that a Turing machine can basically do any computational process. It can emulate anything that your computer can do. And yes, I mean anything. So it can emulate the process of playing music or playing a video game or playing a movie. It can emulate anything that involves reading data and outputting data. And the only difference between our computers in this simple model is that our output is on kind of a linear strip, whereas the computer has much more memory available to it, and it can interpret those 0s and 1s and turn them into, say, a particular sound or a particular pattern of pixels on your screen. Okay, so this is kind of the first glimpse at a very powerful idea, the idea that a Turing machine is a universal machine. All right, and that's it for this video. Thank you for watching.